welcome to the last video of our geometrics for geometry unit. We're going to go ahead and talk about surface area. Just like the volume, it is in section 10.7 of the online textbook. So what is surface area? Surface area is the amount of space that covers a solid. Think about as you wrap presents this year, when you are picking the amount of wrapping paper that would go over a package, if there's no overlap, then the amount of wrapping paper used to wrap an object would be considered its surface area. As you can see in here, we have a box, and this would be the solid. And if I were to separate some of the edges from the faces, we would get this little structure. So we see that this would be one of the faces, the rectangular, big rectangular faces. This would be one of the small rectangular faces. And then if we were to calculate everything on here in terms of its area, in other words, the area of this little rectangle, this little rectangle, this little rectangle, this rectangle, this rectangle, this rectangle, and add that together, we would get the surface area. Since it is an area, it is measured in square units. So we have a bunch of different formulas. Some we could extend even farther. I tried to pick ones that were common and easier to memorize. Rectangular prism is probably the most popular one, or I shouldn't say most popular, but the most recognizable. If you have a rectangular prism, what that means is that each side of the prism is a rectangle. Then the surface area is 2 times 2 dimensions plus 2 times 2 of the other dimensions plus 2 times the other combination of the dimensions. Basically, we have 6 different rectangles, each of different size, where 2 of them are the same size, so we just double that up. A pyramid, depending on its base, so that base could be a square, a triangle, a pentagon, a hexagon, and whatnot, any of those choices. That's what the B would be. So if it was, for example, the pyramid had a square base and the side of the square was 5, then the B would be 5 times 5, which is the area of the square. P represents the perimeter of the square. So for example, if I have that base square that is a length of 5, then that's perimeter would be 20. We take half of that because the pyramid has triangular sides, except for its base. And S stands for slant height. We'll talk about slant height. We'll be able to show how to calculate that in a moment. But basically, if we were to put a ruler along the side of the face of the triangle, we would get that measurement. Then we also have the prism. So a rectangular prism is a particular prism, but if we had any type of prism, then that big B would again be the base of the prism. P would be the perimeter of that base, and H would be the height of the structure. Cone, we have slant height again. Cylinder is pretty much just 2 pi r h plus 2 pi r squared. And then the sphere is 4 pi r squared. Let's go ahead and do some practice problems. Example. We're going to find the surface area of a pyramid with a square base of 5 inches and 10 inches, and height of 10 inches. What we have here is a square base, and then we have sides of a triangle on there. If we were to draw a netting, we would have a square base with 1, 2, 3, 4 triangles. Now, we know that these are 5s because it's a square base. Now, the thing is that we're given a height of 10 inches here. But what we need to know is this here. Oh, that's too dark. Or no. Here we go. We need to know this. In order to find the slant height, we need to use Pythagorean's theorem. Remember the Pythagorean's theorem is a squared equals, or a squared plus b squared equals c squared, where c is hypotenuse. Essentially, we need to find the hypotenuse of the triangle, of a kind of a right triangle that we can kind of see where the 10 would be the height and the 5 would be the base. Or in this case, 10 would be seen as A and 5 would be seen as B. So we need to find the C essentially. So C, or S in this case, because it is the slant height, that's the variable we used to denote slant height, is going to be equal to the square root of my 5 squared, and I'm going to add that to 10 squared. Now this is going to be approximately 11.18. It is not a perfect square, so we have to approximate it. This is not the surface area, this is just the calculation for the slant height. Now if I want to find the surface area of this pyramid, I'm going to take the area of the base, and then I'm going to add 1/2 times the perimeter times the slant height, which in this case is 11.18. So my surface area is going to be 25, because 5 squared is the area of the base, that is this area of this square right here. We are doing 1/2 because we have a triangular base. Or so we have triangles on there. P is the perimeter, is going to be 20, and then we have S as our slant height. So 5 squared plus 1/2 times 20 times 11.18. So our surface area is going to be 25 plus 10, because 1/2 of 20 is 10, times 11.18. So we're going to have a total surface area of 136.8 inches squared. So when you're dealing with slant height, you'll have to use the little square root to find those values. Let's look at another example. Let's find the surface area of an equal triangular prism with sides 7 centimeters and a height of 9 centimeters. This time we're going to have a triangle, but then we're going to have an extend so far this way. What we're given is that the sides of this triangle are 7, 7, 7, and that the height is 9, whatever that is. In order to find the surface area, we need to know the area of the triangle, and we do that twice because there's another one over here. Then we'll need to figure out the area of each rectangle here. Now, there are 3 of these rectangles in green, and there are 2 of the triangles in yellow. So the surface area, by definition, is going to be 2 of the triangles, 2 of the areas of the triangles, plus 3 of the area of the rectangle. Now, of course, our formula sheet says that it's going to be, the surface area is going to be 2 times 1/2 base times height, where 1/2 base times height is the area of the triangle, plus 3 times length times width, which is the dimensions of the rectangles. So we have surface area is equal to 2 times 1/2. We know 7 is the base. The issue, though, is that we don't know what the height is. The height is going to be whatever this is. We don't know that, but we're going to find out using slant height formula. Because what we have is another right triangle, but I need to know this number here. Half of that leg is going to be 3.5, and I know that my slant height is 7. So we're going to use that formula backwards. So over here, we're going to do some extra work here. Okay. Oops. I might need more room than that. So we're going to do some work up here to find that blue line. We know that Pythagorean's theorem says that if I have a squared plus b squared, I get c squared. Well, here, my one leg is 3.5 squared, I do not know my other leg, but I know that my slant height, or my hypotenuse in this case, is 7 squared. I'm going to subtract the 3.5, so I get 7 squared minus 3.5 squared, and then I'll take the square root of that. So we're going to do 7 squared, which is 49, then we'll subtract 3.5 squared. We'll get 36.75, and then we're going to take the square root of that. So B, in this case, is going to be 6.062. Now, B is another way of saying our height. So maybe that's a little confusing. I do apologize. This is essentially our height in this case. Height, 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 height. So what we're looking for was this right there. So now we know we have 6.062. Now we're going to add 3. For the rectangle now, we're going to add 3 times 7 plus 9. Whatever this total is, it's going to be the surface area. Now 2 times 1/2 is 1. So basically we have 7 times 6.062 plus 3 times 7 times 9. So we're going to get 231.434 centimeters squared. Again, we took the area of each of the sides and added them together. We could either use the formula, or we can look at the definition of surface area and then use each individual formula and put them all together. Now let's look at some pictures. We want to be able to find the surface area of a cylinder and another cone. So in the cylinder, we know that the surface area of the cylinder is equal to 2 pi r squared plus 2 pi r h. Essentially, we're looking at the area of the top and the bottom, which are both circles, and they are encompassed by this part here. Now the area around, which we could see it as a label of a can, is equal to this, where 2 pi r is considered the one dimension of the rectangle, and h is the other measurement. So for this one, we already know our r is 3. So r is 3, and 9, or h is 9. So all we got to do is plug it in. Surface area is equal to 2 times pi times 3 squared plus 2 pi times 3 times 9. So surface area is going to equal 18 pi plus 6 times 9, which is 54 pi. So then 18 plus 54, 72 pi. If we wanted an exact answer, we have found it. Don't forget the 2 there. That's it. That's the surface area of the cylinder. It's simpler than doing a pyramid or a cone. So let's look at this cone now. In order for us to find the surface area of the cone, we need to know this number right here. For those that recognize their Pythagorean triples, you'll notice that this number, that x, is actually going to be 10. Now we find that by taking the square root of 8 squared plus 6 squared. 8 squared plus 6 squared is 100, and the square root of 100 is 10. Now we can find the surface area. The surface area is going to equal the area of the circle, which is going to be pi times 6 squared, plus the area of that cone, which is going to be pi r 6 times the slant height, which is 10. So surface area is going to equal 36 pi plus 60 pi, which is a total of 96 pi. Now, because the units are not stated, we're just going to write units and squared. All right. Will be a compound figure. So here we have half of a sphere and a cone. In order to find the surface area, we need to find the surface area of the cone that is exposed and the surface area of the sphere that is exposed. Since half of the sphere is missing, we are only going to need half of the surface area of the sphere. Because the sphere is next to the bottom of the cone's surface area is not going to be part of our total. Before we can find the surface area of the cone, we need to know this here, the slant height. So we're going to find the slant height first. That is going to be the square root of the height of the cone, which in this case is 10 squared, plus the radius squared. Now the diameter is 6 centimeters, so the radius is going to be 3 centimeters squared. Now, of course, this is going to be the square root of 109. This is approximately 10.44. Now that we have this, we can find the surface area of the structure. So the surface area is going to be the surface area of the sphere, which is going to be half of what it would normally be, plus this part of the cone. So we're going to ignore the pi r squared, and we're just going to do pi times r times the slant height, which is 10.44. All we got to do now is calculate this, and we're good to go. So we're going to have 4 divided by 2 is 2. 2 times 9, because 3 times 3 is 9, is going to be 18 pi. And then we have 3 times our 10.44, which is approximately 1.32 pi. We will add those together because they're both pi, so the surface area is 49.32 pi. And of course, we could change pi to 3.14 to find even more approximate answer. This is already an approximate answer because we had to find the square root of 109, which is not a perfect square. 109 is not a perfect square, so the square root of 109 is not an integer. But we can calculate it like this. But if we wanted to continue simplifying, we would multiply this by pi. And we would get 154.95, and then we'd do centimeters squared.